Hi, welcome to the Model Management IPM demo video. In this video, I'll be showing you all the things that you can do with the Model Management IPM. This is going to be a step-by-step guide, so all of the files I'll be uploading and using can be found right here in the demo folder. I am going to now, without further ado, make a system with this IPM installed. Let's name our system demo. We can import IPMs using this helpful toolbar right here. And you see an error, but we can just refresh to get rid of it. So you see 16 services. It's a lot of services. We need a lot of services to power the backend of the model management stuff. And we'll be carrying out all of the UI flows inside of the model management portal that you see right here. But before we can access the portal, we have to create a user with the role administrator. The reason it is an administrator is because there is some dynamic permissions upgrading as you create new models and create new jobs. And I have configured my code to only increase permissions for the administrator role. So now let's log into the portal with the test user that I've created. Chrome thinks I am making a password using a data breach. I am okay with that now. It's just a demo user. And we could click on this preview button here in the portal to expand this bit. So we see three tabs. The models tab and the jobs tab are sort of its own thing. And then the pipelines tab is sort of its own thing. The models tab is where you upload models into the Clearbase system. The jobs tab is where you set up retraining models, retraining jobs that retrain models. And then the pipelines tab is where you can create inferencing pipelines, but it is more powerful than just that. Today I'm going to be mainly showing you how to use this pipeline, this model management stuff through one example, and that is with the iris model. The iris model is a classical machine learning problem where you try to predict the species of an iris genus flower given its sepal length and its sepal width. And I think there's one more, maybe it's color. Maybe that's the attribute. So I have actually already initially created an iris model with this model.onyx file that you see in a demo folder. If you select certain edges here, this model will be directly deployed to those edges. Right now, we don't need that. And I know from my initial training that the accuracy is, I believe, 75%. I only trained on 50 samples, so it's not the most accurate model out there. And perhaps the retraining is going to make it better, hopefully. Let's hit create. And now I want to set up a retraining job to further improve this model over time. But before that, we need new data that flows into the system that a job, takes to retrain this model on. And I have actually already imported this iris model, and that also comes with the IPM just as a demo. So if you're not using this, you can just delete this. But realize that I have this interesting create a timestamp column here, and that allows the model management IPM to determine whether or not one sample should be used in the retraining or not. If the created timestamp seems to be more recent than the last retraining, then we can use it. If it's older, then we have already exhausted it. So I have 156 samples here. This is a lot better than the 50 samples that I initially trained with. So hopefully the retraining results will be better. Now let's set up a retraining job to do what I just said. The base model we want to retrain on is iris. There is no training edge yet, and we need to specify one. So I need to come over here to create a new edge. Now I am going to select my personal Ubuntu machine as the retraining edge. In reality, you might be using some sort of remote machine that is always on and ready to go, because I quite often shut out my laptop, and if the timer ticks when my laptop is shut off, then I skip over the job. So yep, the edge is already set up. That's how easy it is. If I give it a refresh, I should be able to see it connected. Nice. So now if I refresh this thing, I can select training edge. I want to manually train and click on a button whenever I want to do the training. So I'm going to select none for how often I want to train. I want to update the existing model. Now, if I select this option, what it does is that when I create a new model, when the retraining job creates a new model, it's going to append to a model row in the models tab as opposed to creating a new entry. And usually that's what you want. I'm going to upload now my local scripts and environments into the edge for it to retrain. So first of all, I need to upload the retrain requirements text file. And now I need to upload the training scripts. And let's think about what we have here. We have here the iris model. And by the way, I forgot to mention this earlier, but this iris model was a .onyx file. It is an onyx model. We have an onyx model here. We have a training script. And we have the requirements file that probably specifies the libraries that the training script uses. But we need to actually upload some additional files here. And specifically, we need to upload the model weights file and actually a pre-processing file as well. And that is because the model weights file we need to upload because we can't just extract the weights out of Onyx and then somehow integrate that directly with the TensorFlow training code. It's way easier to just keep everything TensorFlow. And that's why we need to upload the TensorFlow meta file, like the model weights file, into the retraining job as well. So I've included that in the demo folder as well. And let me drag that open. And let's take a look. This is what is in the additional output folder. As you can see, there's a metadata file, and this right here is the pre-processing file. And in fact, this is not exactly a pre-processing file. This is a simple file that allows the translation between strings into numbers. So this is a categorization file, we should call it. But you can't just determine this out of the Onyx file and the retraining script, so we do need to upload this. This is determined with the initial batch of data. So we want to retrain on collection data. We have our iris collection there. And this is the simple query to query all of those data. But there's this new data only checkbox here. And that deals with the new data that I talked about earlier. If you select this button, only the newest data are going to be sent to the training edge during retraining. If you don't select it, the entire collection or all the data resulting from the query are going to be sent to the training edge. We do need to specify the collection name because this could be ambiguous. And this is it. There's one more thing here. I want to specify the evaluation metric accuracy. Now, Clearblade, the model management IPM, can't just magically look through your models file or whatever to scan an accuracy variable. So what we do to sort of bring this accuracy of your model back into our system is that you have to output a accuracy file at a particular path that we have dedicated here. And after your training, the model management stuff is scripts are going to look for the accuracy path, and it's going to bring the value at the accuracy path into the Clearplay system. So now the retraining stuff is all configurations is all complete. I'm going to hit create, and I am just going to hit train immediately. We can give it a refresh and we can see that it's undergoing. So I'm going to come back now when the job is finished training. So now I want to talk to you about pipelines. I have here already established 5 pipelines. And the first pipeline that I want to showcase you is the basic algebra pipeline. In a pipeline, there are 4 different types of nodes: a library node, a model node, an Mqtt subscription node, and an Mqtt publish node. In this case, we have a bunch of library nodes along with the 2 default nodes, the inbound topic node and the outbound topic node. So I am just going to start this and let's see what happens. Now the pipeline is listening, as you can see right here, and we can now ping the inbound topic with a particular input. So let's do perhaps 119. If we now come to the bottom, we can see the result being outputted here. 119 plus 1 times 3 is indeed 360. Now, pipeline library nodes have some extra specifications to them. First of all, they must be prefixed with the name pipelib underscore. And second of all, they must have an exec function. So they will look something like this. The exec function is returned. So library nodes allow you to practically run any JavaScript in your pipeline. You can really do anything. But of course, we want to abstract away more things, and that's why we have the model node and then the Mqtt nodes. So next up, I actually want to display another feature of pipelines, and we're still going to be dealing with model nodes, but I want to demonstrate the asynchronicity of pipelines. In this example, I have 5 library nodes whose only objective is to return results from its function, from the exec function, after 5 seconds. Now, if the pipeline was synchronous, we would expect this whole process to take 25 seconds. But because it's asynchronous, this is only going to take 5 seconds. So I'm going to test the pipeline. So first of all, we see that I have some trials done before, but now let me test the pipeline with any input because it doesn't really matter here, as the library nodes are not using the inbound topic data. And we see that around the 5th second, we get the okay. And it's returning okay because I've written the code such that each of these pipelib wait 5 second nodes return a promise who resolves to the value to the string okay. The next pipeline that I want to showcase you is the halting subscription pipeline, and that displays to the Mqtt subnode. So let me stop this pipeline, in fact, and let me restart it. When we restarted, this pipeline is not going to run until something pings the inbound topic. But there's just one more node that has the same behavior, and that's the Mqtt subnode. If I ping the inbound topic, naturally it's going to flow to the next node. The data that we pinged at the inbound topic is going to flow to the next node. Now, the next node is an Mqtt subnode. This node halts the current pipeline, halts the current branch of the pipeline, you may think of it as, and it doesn't move and pass the results forward until it receives a message. And in fact, it only passes its results forward, so the message that it received. So in this case, the inbound topic message doesn't really matter, as the Mqtt subnode kind of ignores it. So I'm going to ping this pipeline with, again, anything, because it doesn't matter. And if we refresh and look at stuff, nothing is going to show up. Well, there's something that shows up 4 hours ago. But I can now send a message to the Mqtt subtopic, and I'm expected to see that topic flowing into the outbound topic and seeing it here. I don't have any way to do this natively in the UI, so I'm going to come over here to our Clearblade IoT management platform and send the message to now/read. Subscribe, and let me publish some random stuff. And we should be able to see it here. Now, just as a little showcase, let me try sending something invalid. Now, it might not work here because everything is stringified here. But I can actually come back here. And the error handling works for all kinds of pipelines. But let me try sending something valid. Sending this stuff right here is invalid because this is not interpreted as a string. And I'm going to do OK. I'm going to do a refresh and we get invalid JSON. And it stops the pipeline automatically. The last example I want to show you, I am actually going to delete for now and then create from scratch. I'm going to come over here to Iris, the model that we have uploaded in the beginning. And I am going to click Create Inference Pipeline. This makes a simple pipeline with an inbound topic, an outbound topic, and then a model node stashed in between. Generally speaking, you do need to do a little bit more configurations. For example, your inbound topic message might need to be pre-processed to fit what the model accepts. Now, you often see the use case of the inbound topic message being an array of JSONs, right? In that case, models don't accept strings. You have to convert it down. But in this case, just to simplify things, I'm going to ping the inbound topic with value that is directly inferenceable, if that's a word, by the model. So I know that the Iris model accepts 4 columns, 4 attributes, the sepal length, width, and the petal length and width. And those correspond to integer values. I'm going to simply make up some values. And I am typing here a double array because models support batch inferencing by default. And we see that less than a minute ago, we get this result back. Now, how do we interpret this result? Well, that depends on your particular model. In this case, I have a classifier model. And so usually each element in this subarray corresponds to one particular output label. So this label, this value here, might correspond to the percentage that the model believes the input is of species, let's say Virginica, because we're trying to determine the species of a particular iris genus flower. Perhaps this means that it's 78% bearded iris, and this one means 9% versicolor iris. It depends on your model, and it depends on the type of your model. If it's going to be an image model, this is going to be a lot different. So, you generally have to write your own custom function to do this. This is one flaw of the current system that we have, and that's whatever pre-processing or post-processing code that you have in Python or your original machine learning pipeline, you can't directly migrate it to TypeScript and into our environment, or JavaScript, of course. You have to sort of write code again. Now, of course, we have these processing libraries such as Danful that assist you in this process. So this concludes my Clearblade Pipelines video. I have one node yet to cover, which is the Mqtt Subnode, but that one should be intuitive enough. And thus, this will also conclude my model management IPM demo video. Hopefully this video is of use to you, and good luck working with them. Thank you.